Okay, so hi everyone. My name is Tim and I'm an Android developer here at Infinum. And for the last year, I've had the unique opportunity to work with Android Automotive. So today I will share some of my experiences. So first, something general about automotive. So automotive is an operating system and a platform for car infotainment systems. And I think we all know what an infotainment is, but essentially this is the main screen in the car that the user can interact with. And it's important to know that Android Automotive is Android. It's not like a fork or a parallel development of Android. It's the same code base that's running on your phone or on your tablet. But Automotive also extends Android. So since this is a new environment, there are of course some new requirements. For example, we have some new APIs that we're going to see later. And now to clear maybe the confusion with the naming, we have Android Automotive and Android Auto. And Android Auto is basically just an app that is projecting your smartphone apps to the infotainment in the car. So the main thing is that these apps are actually running on your phone and are just being projected. But the automotive system is a standalone operating system that is running on vehicle hardware. So essentially this is just that it means that there's an Android device somewhere in the car that's hooked up to the main screen, and then any apps that are running on this device. You don't need any external phones or anything like that. Also, you might be wondering why would manufacturers decide to switch to automotive or to adapt automotive. First off, Android has been around for over a decade, so it's a proven platform. Manufacturers are confident that this can be a long-term solution to the infotainment system. And just because this Android has been around for so long, it also means there's a large pool of experienced developers available for it, so manufacturers can quite easily, let's say, acquire experienced developers. Also, it massively reduces costs and time of development. Of course, it's much easier to adapt the system and make it suit your needs than it is to develop a system from the ground up. Also, significant customization is possible. So this is basically open source, so there's not a bunch of restrictions here. Also, it can give you access to Google Maps, Google Assistant, and the Google Play Store. So again, this is just something that manufacturers wouldn't need to develop themselves. They can just use these solutions provided by Google. And automotive can come equipped with gas or no gas, and this stands for Google Automotive Services. And these are mostly the three things that I just mentioned, so the maps, the assistant, and the Play Store. And in order to have this available in the vehicle, the manufacturer needs to conform to some sort of standards defined by Google. They need to pass some compatibility tests to obtain the licenses for this, but this is completely optional. They don't need to do it. And what would automotive apps be used for? I've split this list in two categories. The first one are the pre-installed apps or the apps made by the OEM. So this would essentially be any app that is actually controlling the car functions, like apps for controlling air conditioning, selecting drive modes, controlling windows. So it would be quite dangerous if just any app from the Play Store could change these things. So they are mostly limited to the pre-installed apps. Then we have third-party apps, and this is essentially just any app that you can imagine for your phone. You can also have it here. Some example would be navigation, media, video or streaming apps, even gaming apps. But one thing to note here is that all of these third-party apps can, of course, also be pre-installed by the OEM. So I guess all cars will come with navigation and media already available. A bit more about the special APIs. So first thing to know is that these APIs are available in every, or at least in the latest Android SDKs directly. You do not need to pull these dependencies from Maven or from somewhere like that. They are available in the SDK. And how they work is that they are structured into a bunch of car managers, and each of these car managers has a specific use case. For example, we have the car property manager, the car audio manager, the car Bluetooth manager. I won't go into too much detail here, but essentially, if we go back, our app is using one of these managers, and then this manager is interacting with the vehicle whole layer. And this layer is basically just an abstraction over the car or the car ECUs. And this vHole layer has what we call vHole properties, and this is the main way that our apps can interact with the car. So it's through these vHole properties. For example, if we want to read the car model, there exists a car model vHole, and we can simply read this property and determine the car model. If we go forward, here will be some examples of the of actual cars that have it. So what you see here is the infotainment of the Polestar 2. This was actually the first production car which came equipped with Android Automotive, and we can see it looks very much like just Android that you have on your phone. Maybe there's a bit of a different layout. You have the status bar, the navigation bar, this like grid system with 4 widgets. Then at the bottom you have the ventilation control and the home button. But this looks very much like Android, not much has changed. Then we have the screen from Volvo, so the app selection screen. And here we can see that it has Google Maps, Google Assistant, and the Play Store, which means it has gas or Google Automotive services. Now we have a bit of a step up. So this is the Maserati, and you can see this is much more custom, much more modern. You wouldn't be able to tell that this is Android, I think, just from this image. And again, we have some navigation, the status bar, and one thing that's common, or I've seen it in most of the infotainments, is this triple widget layout that we have here. Now if we take a look at the Porsche, again we have the app selection screen where the user can scroll up and down, open any app that they want. On the right, this one also has a passenger screen, and we can see that some app for driving is open, like it shows you G-forces, the speed, and so on. Now one thing to note here is that this car does not have Google Maps as we see here, but it has some custom navigation solution, which means it does not have gas. And just a final example from Alfa Romeo, again we see a similar structure with the 3 widgets. And before we go to the demo, I would like to mention one more thing. So as I said, the main thing of how we interact with the car is through these vHoles. And there are 2 types of vHoles. One of them are the system vHoles. This would be the default vHoles that Automotive would provide. For example, the car model, the year in which the car was made, or the current speed. Then we have the vendor properties, and these are basically custom properties that the manufacturer can define. So of course each manufacturer will have separate needs, and in reality, at least from my experience, this is mostly the vHoles that we interact with. And then to use these vHoles, our apps need to have the correct permissions, and this is exactly the same system that is used on normal Android. So the same way that you define permissions in your manifest, here you also have to define permissions in your manifest. And for example, if we also want our app to read the car model, there exists a car model permission which we need to have, and if we don't have it, we'll get an error where we try to read this vHole. And the permissions are also split into 2 categories. One are normal permissions. These are permissions that are available for any app to request. Then we have the signature/privileged permissions. And these permissions can only be requested by apps that are signed by the development key, which means that only OEM apps will have them, so basically the pre-installed apps. And now if we switch to the code, first I will do a quick tour of the Automotive emulator. So here you can see this is basically available in Android Studio. You can download it yourself, you can just run it. And if we look at the dashboard, you can see again this widget layout that I mentioned. Then we have at the bottom some ventilation controls, some phone management, and here we have the app selection screen so that we can see all the apps that are installed. And I would just like to quickly show you the settings where it's clearly visible. This is just Android, right? You have your apps, you have your permissions, notifications, and everything. And for the purposes of this presentation, I've made a very simple app. So all that it's gonna do is that when I press this button, it's gonna fetch the car model. That's it. And if we take a look at the code, oops, oh, it's not full screen. If we take a look at the code, here we have our view model of our app, which is using a custom car communication API class. And this class just has an observe property method, which we will use to observe the car model vHole. It's called info model. And if we go into this class, we're going to see all of the system vehicles that I mentioned. So these are the default ones provided by Automotive. And these are basically just IDs that we can use to determine what we want to fetch. If we take a closer look at our custom class, this is essentially just a wrapper around the car property manager. So this is one of the managers as I mentioned before. And it's not really important to examine this code, but what's important here is that this car property manager has a method called setProperty, and with this method we can simply define the vehicle ID and the value, and when we execute this code we're going to write this value to this vehicle. So this is how we can set a vehicle value, and similarly we can observe properties. We have some sort of a callback in which we again define the vehicle ID, and if we go here we can see that this is going to be called anytime there's a change in the vehicle. So let's say that you're observing the speed, this would be repeatedly called when the value changes. And what we do here is we just send this back through the flow, and this is exactly the flow that we're collecting here. So okay, the info model is not going to change, so this will only be called once, but once we click the button, we'll simply update the state. And when I do this here, you will see that we fetch the model, and this is just some string that's defined in the emulator settings. And similarly for if you want to set property, as I showed you, we just have this set property method. We define the vehicle ID and we set the new value. But this will not work with the emulator because this vehicle is protected by the signature permission. So mostly all of the vehicles that we can write to are protected by the OEM, so this we cannot do here. One more thing I want to mention is just quickly show this permission. So it's exactly like on your normal phone. This is the permission to read the car model, and the Gradle file, as I mentioned, this is not like a dependency that's pulled from somewhere. It's used direct. It's already included in the SDK, so we just need to use this line here to get access to these APIs. And now if we go back to the presentation, you might be wondering how to actually test this app. Like for a real life scenario, we would need a car, but this is most of the time not really the case. So if we take a look at this graph again, here we can see that the top 4 layers are basically our app and the automotive. And one thing is missing, and that's the actual car underneath. So beneath the vehicle layer, we're going to need something. And here we just use some simulation program that's in-house created. And essentially what this thing does is it's just mimicking the car behavior. So our setup would look like this, that we have our automotive box hooked up to our laptop, then we push our app on it, and in parallel we run this simulation program. And then what this thing does is that our app is just communicating with this program, so we don't need an actual car for development. And yeah, this is mostly used during development or internal testing. Then for final verification, of course, everything needs to be tested in an actual car. And as with any new platform or technology, Android Automotive brings for us new things to learn. The first thing would be a new domain. So we would be talking a lot about car stuff, so we would need to get more familiar with the car domain. This is basically like starting work in an IoT project. You need to get familiar with that IoT domain. Also, there are new APIs that I mentioned. They can be pretty straightforward, as you saw, but still in the beginning you'll need to mess around with them a bit, get to know them. And also the final thing is that you will be probably need to be used to a new UX than on your normal mobile devices, because mostly the apps will be running on bigger screens. So the touch areas will be bigger, and also like the core principle of any app is probably that it should distract the user as little as possible. So it's important that you don't have like complex navigation or just complex interaction in general, because the driver should focus on the road, not on how to operate your app. And there are some new challenges as well, of course. As I mentioned, testing, this is probably the biggest one, at least for me. So as I told you, we use the simulation program, which is fine in most cases, but it can happen that this behavior of this program is not really the same as the behavior of the actual car. which could mean that when you run your app in your development environment, everything works fine, it's great. Then you test it on a car and it's just not working at all. And these things can be quite tricky to debug, especially if you're like me. I mostly then have remote test sessions in the car, and this is just another layer of complexity. Another thing is that's not really common for normal development would be that you would know exactly the screen size and exactly the resolution that your apps will be running on. So a requirement from the manufacturer is actually that our apps are pixel perfect to the provided design. So we actually use pixels, not DPs in our app. Also, there can actually be multiple screens hooked up to automotive. So in my case, we also have a passenger screen. So there might also need to be some extra configuration to make this work properly. And also you might encounter some issues with proprietary stuff. In my case, this was not really the case, but I have a colleague who works on a newer generation of the infotainment. And for example, they got some UI library from the manufacturer, so they could only use components made by the OEM, and this was poorly documented. Its behavior was kind of weird, so they had to do a lot of trial and error to figure this thing out. And just to close off, I want to say that Android Automotive is an exciting new opportunity for Android developers, but as any new opportunity, it comes with new challenges. So yeah, any questions?
What happens with like how you test for different screen sizes, because each manufacturer has a different screen size? Like, can you set it up in your simulation program?
Yes, we actually. Sorry. Oh yeah, how do we handle these different screen sizes if we can set them up in our development environment, basically? Yeah, so essentially we have this Android Automotive box, and that box is already set up to use the correct resolution, or you could even set this through ADB, right? I think you can set the resolution and everything, but yeah, we can set up the exact resolution and screen size, so we can actually test properly even with this.
So is it a software or some hardware that you need to plug in, like your simulation program? Is it?
No, this is just a program that we run on our computer, and then the hardware is the actual automotive box. So yeah, but we can test properly, like at least regarding the screen size and everything.
Are there like different versions of this Android Automotive, like the different versions of Android?
Yeah, I think, as I said, in each SDK, so in each release of Android, this is also included there. So I guess there are some changes, but honestly, I can't tell you if there are any, that's regularly updated as normal Android. But as you saw, this can be really heavily modified, so the manufacturer will just completely modify this. It's not like they will just leave it stock, like stock Android.
When you test this on real device, I mean, can the manufacturer send you some sort of box or something you can test?
Yeah, do you mean like the actual infotainment screen, or? Yeah, that's a really good, yeah, sorry to repeat the question. If the manufacturer sends us any proper like screens or that are used in the car or the entire system, yes, we have something called a test bench, which is essentially the entire infotainment system. That's exactly the same as in the car, but this thing is just not connected to like car ECUs. So you cannot get car signals, but the entire screen, the exact hardware is the same. So you can, more properly test stuff there. But in our case, we're dealing mostly with actual car ECUs, so changing drive mode, changing that. So these sorts of things, it's also hard to test on the test bench. So yeah, the best way is to just use a car, of course, but that can be quite hard to then acquire the correct model that you have with the correct extra equipment that you want and so on. So that's kind of, a process here.
Did your simulation box also contain some hardware which will detect the speed Like to detect the speed, we need the specific hardware which is available in the car or in our mobile phone. Does your simulation box also has this?
No, the simulation program, it just has a bunch of parameters where we can hard code the values that we want to receive to the app. So let's say we want to set the speed to 15, we can set it to 15, and our app will fetch the vehicle and it will get the value 15. So there are no actual hardware to detect these things.
Any more questions?
Tim, I heard that this is your first presentation that you gave in your life for a bigger audience. So how did it feel? Were you stressed about it? Were you happy with the presentation?
I think it went okay, I would say. The hardest part were the upcoming week or the upcoming 3 days before the presentation. So now I'm just glad that it's finished, to be honest.